Hello students, this is the second lecture on chapter 5, and in the first lecture video we have looked at the definition of simple linear regression and correlation. At the same time we have discussed about how correlation coefficient is calculated for quantitative data and qualitative data. Therefore, in this second video or lecture, we are going to deal with how we can calculate, A and B or R, or the so-called the estimated value of independent variable or y hat. Therefore, from this slide or from this formula, we need to understand the estimated model for dependent variable or y hat is given as y hat is equals to a plus b times x, and when we calculate a, we use this formula. A is equals to y bar minus b times x bar, where y bar is the mean of dependent variable and x bar is the mean of independent variable. On the other hand, in order to calculate the value of b, we use this formula. B is equals to the sum of x times y minus n times x bar times y bar all over the sum of x square minus n times x bar square. Let us deal with how a, b, and estimated value of dependent variable are calculated by using one case or one example. The following data shows the score of 12 students for accounting and statistics examinations. And by using this data, we are going to calculate a simple correlation coefficient. As well, we are going to fit a regression equation of statistics on accounting using the LS or least square estimates, and we are going to predict the score of statistics if the score of accounting is given as 85. And in this table we are given with the score of 12 students here in this column on accounting examination, like in this column, and on statistics examination by this column. Therefore, the first thing that we need to do is we try to represent the test results on accounting examination by x, so that x is, let's say, it is independent variable, and y is the x is independent variable and y is dependent variable, which is the variable that represent the test result, the results on statistics examination. Therefore, when we add the examination result on accounting here, the total of this column will be 687, and the total of this column is about 741. Therefore, this is the sum of y value and the sum of x value. When we square the accounting examination results of all 11 to 12 students here, we obtain these kinds of results. And the same is true when we square y, we obtain the results stated or present in this column. And when we compute the product of x times y, we obtain the results that are present this way, which means x here is, for example, for student or for the first student, x is 74, y is 81. Therefore, 74 times 81 is about 5,994. And we do in this way for the rest of the students, and we will get these kinds of results. And the total of this column or xy, or the sum of xy, will be about 48,407. And before we get forward to the simple correlation coefficient between x and y. Let us compute the mean of x and the mean of y variable. The mean of x or accounting examination results is 57.25, which is obtained by adding the results present in this column, then dividing by 12. And the mean of statistics examination results is computed by adding together the statistics examination results of 12 students and dividing by 12, which is about 61.75. Therefore, simply x bar or the mean of accounting examination result is computed by dividing 687 by 12, and y bar is calculated by dividing here 741 by 11 by 12. That will obtain these kinds of results. Therefore, let's get forward to the first question. Let us calculate the correlation between x and y, which is R. The formula that we use to calculate or compute R is this one. So let us substitute figures from the given data. Here R is equals to n in our case is 12 times, here 12 times the sum of xy here in this column. The total of this column or the sum of this column or xy is about 48,407, so that we take the figure here, minus the sum of x, here the sum of x or this column is about 677, so that we take here, times the sum of y, here the sum of y, or the total for this column is about 741, so that we take the result here, divided by square root of n is 12 times the sum of x square. Here the total for x square column is about 45,591, so that we take here minus the sum of x. Here the sum of x value is about 687, then we square it, times square root of n, which is 12 times the sum of y square. Here y square, the total for the y square column here is 52,525, minus the sum of y. Here the sum of y or the total for y column here is 741, then we square it. Finally, we will obtain or will get this result 0.9194, which is the correlation coefficient between x and y, which is 0.92. This implies that the two variables, i.e. x and y, are positively correlated, which means y increases as x increases and y decreases as x decreases, so that there is a positive or direct correlation between x and y. Let us proceed to the calculation of B. The formula we use to calculate B is this one. B is equals to the sum of xy minus n times x bar times y bar all over the sum of x square minus n times x bar square. Let us substitute figures from the given data. You are given with this data. Therefore, B is equals to the sum of xy. Here, this is xy column, and the total of the sum of this column shows the figure of 48,407. Therefore, we take this figure, this formula, minus n is I mean to say 12, so that we take this times x bar, or the mean of x variable is 57.25, so that we take here, times y bar, or the mean of y variable is 61.75, so that we take here, all over the sum of x square. This is x square column. Those are the sum or the total of this column shows a figure of 45,591. So that here we take the result. then minus n is 12 times x bar square. X bar here is 57.25, so that we square it, and finally we'll get 0.9560. This is the value of b. After we obtain the value of b, we can easily determine a by using its own formula. A is equals to y bar minus b times x bar. Therefore a is equals to y bar, or the mean of y variable is 61.75 here, minus b is, we have obtained there is the result of 0.956, so that we take here, times x bar, which is a mean of x variable, which is determined to be 57.25, so that we take here, and finally the result of a is 7.0194. This is how we can determine the value of b and the value of a. Therefore, the estimated y hat, or the estimated model for dependent variable here is, or y hat is equal with a plus b times x. Therefore, y hat is equals to a in our case is 7.0194 plus b in our case is 0.9560 times x. This is the estimated regression line, or the equation which for the regression line that shows the correlation or relationship between x and y. When the value of x is given as 85, therefore the estimated regression line will have the value of 88.28. This is obtained by substituting the value of x here, 85, instead of x in the estimated regression line equation. Therefore, y hat is equals to here 7.0194 plus 0.9560 times x. The value of x is given as 85. Therefore, finally we will obtain 88.25. This is the way by which we can calculate the the constant term, the y-intercepts a and b, at the same time the way by which we can derive the estimated regression line equation, and the way by which we can also determine the estimated value of dependent variable when the value of independent variable is given for us. Let us proceed to how the coefficient of determination, or R square, is computed. We applied this formula. Coefficient of determination, or R square, is the sum of bracket y hat minus y bar square, the bar all over the sum of y minus y bar square, where R is a simple correlation coefficient and R square is coefficient of determination. And this R square gives a proportion of the variation in y, or dependent variable, that is explained by the regression of y on x. On the other hand, 1 minus R square gives the unexplained proportion, and it is usually known as coefficient of indetermination. So that after we have obtained the coefficient of determination, we can simply deduct the result from 1, and we can obtain the coefficient of indetermination, which is the unexplained proportion. For example, for the previous example, we remember that R, or coefficient of correlation coefficient, is about 0.9194 here from the first question, 0.9194. Therefore, R square will be 0.8453, which means we may also compute this result by using this formula, and finally we can obtain the R square, or coefficient of determination, which is about 0.8453. This implies that 84.53% of the variation in y, or dependent variable, is explained by the regression of y on x, and only 15.47% remains unexplained, and it will be accounted by the random term. This is the way by which coefficient of determination and the coefficient of indetermination are determined for two variables, for dependent and independent variables. Let us proceed to the calculation of covariance of two variables, x and y. The covariance of x and y measures the covariability of x and y together, and it is denoted by s sub xy, s sub xy, and is calculated by using this formula, the sum of xy minus n into x bar times y bar all over n minus 1. The other hand, the relationship between the coefficients is determined by using this formula. R is equals to s sub xy divided by s sub x times s sub y, which implies R squared is equals to s sub xy squared divided by s sub x squared times s sub y squared, or R is equals to b times s sub x divided by s sub y, which implies b is equals to R times s sub y divided by s sub x. When we fit the regression of x on y, we need to interchange x and y in these all formulas. Therefore, x hat is equals to a1 plus b1 times y, which implies b1 is equals to the sum of xy minus n times x bar times y bar all over the sum of y square minus n times y bar square. On the other hand, a1 can be calculated by using this formula. a1 is equals to x bar minus b1 times y bar, where r is equals to b1 times s sub y divided by s sub x. So that in these formulas, x represented dependent variable and y represented independent variable. These are formulas or equations we use to measure the covariance of two variables, dependent and independent variables, or x and y. Let us proceed to the choice of dependent and independent variable, or how we can determine which variable is dependent and which variable is independent when we are given with two variables. In correlation analysis, there is no need to identify the dependent and independent variable because of R is symmetric. But in regression analysis, there is a need to identify dependent and independent variables. If b sub yx is the regression coefficient of y on x, therefore b sub xy is the regression coefficient of x on y, then R can be computed by b sub yx times s sub x all over s sub y, which is equal to b sub xy times s sub y divided by s sub x. This implies that R squared is equals to b sub yx times b sub xy. Therefore, we need to note that in order to calculate, or in order to determine if a regression equation is x on y or y on x, or whether one variable is dependent or independent, we have to use this formula, which is R squared is equals to b sub yx times b sub xy. Let us deal with one illustration or one example in order to be familiar with the choice about dependent and independent variables. If we assume the regression line between age, which is denoted by x, and weight, which is denoted by 1, y of male students are given as y 4y minus 15x plus 530 is equals to 0, and 20x minus 3y minus 975 is equals to 0. Let us determine which regression of y on x or x on y, or which variable is dependent or which variable is independent. We'll assume one of the equation as regression of x on y and the other as y on x, and then we calculate R. Let us assume that for y minus 15x plus 530 equals to 0 is regression of x on y, and 20x minus 3y minus 975 equal to 0 is regression of y on x. And let us write them in terms of standardized form, which means 4y minus 15x plus 530 is equal to 0 is the same with x is equal to 530 over 15 plus 4 over 15 times y, which implies b sub x y is equal to 4 over 15. The other hand, when we standardize the second equation, 20x minus 3y minus 975 is equal to 0, which is which implies y is equal to minus 975 divided by 3 plus 20 divided by 3 times x, which implies b sub yx is equal to 20 over 3. Therefore, r square is calculated by using this formula, b sub xy times b sub yx. Therefore, b sub xy here in our case is 4 over 15 we take, then we multiply by b sub yx, which is 20 over 3. Then finally we'll get 1.78, which is greater than 1. But this is impossible, or this contradiction, because of the correlation coefficient ranges between 0 and 1. Hence our insertion is not correct. Therefore, for y minus 15x plus 530, which is equal to 0, is regression of y on x, and the 20x minus 3y minus 975 is equal to 0 is regression of x on y. This is how we can determine the dependent variable and independent variable when we are given with the equation of two variables. The equation of, when we are given with two equations. This is all about chapter 5, which is about simple linear regression and the coefficient of, correlation. Thank you very much for your time and for watching this lecture. And try to read as best as possible and try to solve exercises presented the chapter 5 of your handout. Have a nice time and thank you very much. Thank you.